Hello, eFesters, and welcome to the ALTAIR presentation of SimSolid. ALTAIR has been a partner with ASME since the beginning of the eFest, and we're happy to be here again in the slightly modified version. My thanks and commendations go out to the eFest ASME crew for pulling together something so quickly and giving us at least something that we can enjoy this year. But as I mentioned, I want to talk about SimSolid. SimSolid is a finite element analysis tool that will result in a tremendous reduction in the amount of time it takes to do an analysis. And as you're going to see here, a massive reduction in the amount of time that it takes to set up an analysis. So what I want to do in this first video here, and we're going to have two videos. This first video, I just want to introduce you to the idea of SimSolid. We're going to run a quick linear structural analysis, and then we're going to post-process it, take a look at the results, and that'll lead us into the second video where we're going to investigate some of the more advanced features of SimSolid. We're going to see some other cool things that SimSolid can do to make your job easier. So the first thing that I want to do is I want to bring some geometry into SimSolid, and I'm going to do that by coming up here either to my project tab and import from file, or I can come to this icon right here, import from file. And this is going to allow me to bring in some geometry. And I've got a drone body file here. The modified version we'll deal with in the next video. But I'm just going to open this up, and you'll see very quickly it's going to open that geometry up. It'll give me a representation of it on the screen, and we'll rotate it in just a minute. But most important, or very importantly, one of the very first things that it's going to do is it's going to open up this automatic connections window here. You're going to see shortly when I start investigating this model that this model is actually uh, about 20 to 30 different pieces put together. And what we want to make sure is that all of these pieces are connected together. And what SimSolid is going to do is it's automatically going to do that for us. It's going to look for gaps and connect them, and it's going to automatically look for penetrations and fix those as well. Now, it's not going to be able to handle very, very large gaps or very deep penetrations. You can adjust these tolerances here. But if you've got very deep penetrations or very large gaps, that's something you're definitely going to want to handle in your geometry tool. But for just standard everyday gaps or penetrations, it'll find those and adapt them. I can change my resolution to increased if I find out it's not connecting things properly. But for the most part, it's going to do it quite well on its own. I click OK, and you'll see over here it's going to populate all of these different connections here, and we'll get back to those in just a minute. But let's take a look at our part first. So let me rotate this around. Now, to rotate, I am holding down my left mouse button and I'm dragging it. To pan the part, I'm holding down my right mouse button and dragging that, and then zoom in and out with my scroll wheel using the pointer as a focus. But we do want to make sure that that SimSolid is as convenient and easy to use as possible, and something that ALTAIR is kind of making standard nowadays. If you come here to Settings, and you come to mouse settings, you'll see that you can change your mouse type to match some of the more popular CAD products out there. Right now it's set for SimSolid, so 3D rotate with the left mouse button, zoom with the scroll, and 2D pan with the right. If I change that to another common one, SolidWorks, you see it's going to change it just a little bit here to adapt to SolidWorks, and then I can set that as the default if that's what I want to use. Now I'm not a SolidWorks user, I'm just familiar with the SimSolid controls, so I'm just going to set that back and click cancel. But that's going to allow you a better transition between your CAD product and into SimSolid. And now as we kind of zoom around and rotate around here, we can see a little bit more of the complexity of this part. I mean, it is a relatively simple part, but it's a number of parts put together. You see that even these arms are kind of broken up into different pieces here, and we even have representations of the bolts that hold this together. And here we don't have bolts in there, but that's okay because SimSolid has gone through and made the connections for us. If I come here, open up my or expand my connections, and I click on any of these, what it's going to do is it's going to show me the two pieces that have been connected together and a representation of those connections. So I can go through, and if I want to, I can investigate to make sure that everything's properly connected together. And you see it's even done so with my little spacers and my bolts here. I'm not going to go through every one of those because I'm pretty confident that it's done a good job of that. But you can go through and investigate and make sure that all of your connections have been properly made. And if they haven't, you can just adjust those tolerances. Now coming back up here, you'll see that I can change my units. Change them to whatever I want, inch, pounds, or millimeters, and then change the actual values within them. And then you'll see that every one of my design studies, and when we get into the more advanced features, I'm going to talk to you about the different design studies, but those are going to show up here, and all of the information for that design study is going to appear beneath it. So the very first thing I'm going to want to do is come to my assembly here, and this icon right up at the top here is my material. These parts have not come in with material. If you're using a system that assigns materials, many of those will come in. In fact, if I come here and you see, if I come to geometry import settings, it will import materials if those are included in your in whatever system you're bringing them in from. In this case, it's just a simple step file. There aren't materials. So I'm going to want to come here, click my material button, and you'll see we have a very, very extensive library of materials. And so I'm just going to come down here to my plastics, and we'll pretend that we 3D printed this thing in its entirety. So I'm just going to come to ABS plastic, and I'm going to click apply to all parts. Now you see here it also says apply to selected parts. I don't have to apply the same material to the entire model. I can select parts, so I'm going to apply to all parts and click OK, and now you'll see all parts will be indicated here as ABS plastic. But if I come to an individual part, and then I come to here and I change that to, we'll just change it to gray cast iron, and I click apply to the selected part, you'll see that that part alone now has been assigned that. So I can go through and I can do multi-selections. So I can apply materials to my parts en masse, or I can apply them individually. And that's it. The geometry is now ready to analyze. That's really all we had to do was just bring it in and allow it to do the auto connections and then assign the material. So the next thing I want to do now is tell it what type of analysis I want to run. And I'm going to do that by just coming up to here. And you'll see we have linear structural, modal, dynamic, and thermal analyses. We're going to start off just running a simple linear structure analysis. So I'm going to click that, and I'm going to say structural linear. And as soon as I do that, under my design study, it's going to add a structural analysis where my advanced solution settings, all of that. But I'm going to leave those alone, and I'm just going to come to define my my analysis. And as soon as I'm in the structure, now the icons along here have changed for my structural analysis. These are my constraints: an immovable or encoster support, a sliding support, a hinge, or a spring support. And then down here, I move into my forces: a pressure, force or displacement, a gravity load, inertial load, remote loads, thermal load, bearing load, or a hydrostatic pressure. So let me define my my constraint first. Sorry. So I'm going to come here to my constraint, and it's an immovable constraint, and I can apply that to a face, an edge, a vertex, or a spot. So I'm just going to rotate my part over, and I'm going to apply my constraint to the bottom of these feet here. Since it's already set for face, all I have to do is click the face. It highlights that. It puts that into there, and now I'll click this. And don't worry that this is no longer highlighted. It is saved in here. The orange is just indicating the active or the last thing that I just selected. So I just go through and click each one of these four faces, and they're all in there. And now if I click OK, I will get these little icons on here. They look like little check marks or little X's, indicating that those four bottom faces are constrained. The next thing I'm going to do is I'm going to apply a force. So I'm going to come here to my force, and I'm just going to say a force or displacement. And again, I have the ability to do a face, an edge, a vertex, a spot. Now, it's not really easy to see until I switch to edge, but there is a square here, kind of representing well, some sort of package or something that's been attached to this, and that's going to represent the force. So we'll imagine that this thing has come down and landed pretty hard, and you know, it could be the camera, it could be the controller, whatever on this drone is going to impart a force. So I'm going to put it on that edge. I'm just going to grab that edge there, and then I just have to come down here and indicate the direction that I want that force to go. And if I need a reference, I can come here to my triad. So I'm looking for the z-axis, but I want that to go down. So I'm going to come here to my negative z, and we'll say negative 20 pounds. And click OK. It doesn't look like anything happened, but because it was negative, the arrows are going to come down from there, so you see them on the inside of the body. And that's it. It's ready to run. And as soon as I've got that set up, you see this icon now becomes active, my little run icon. And had I not been talking through the entire thing and kind of doing a little demonstration, I could have had this in and running in probably about a minute or less. And now this is where you're going to see the true power of SimSolid. I'm going to click this little button right here, this solve button. And as soon as I click it, you'll see this screaming across the bottom here. And as quick as that, it's done. The analysis is complete. It has done a full finite element analysis on here. And in fact, if I right click on this and say info, you're going to see my total runtime, 5 seconds. 5 seconds to do a full multi-part finite element analysis. Now, your results may vary. A far more complex model is, of course, going to take a bit more time, but we are talking potentially orders of magnitude difference in analysis time between this and a traditional FE product. So seconds to minutes are now seconds, minutes to hours are now minutes or seconds, and you're going to see a substantial reduction in time. But now that I've got this, all I have to do is come down here to my result plot. I'll click that. It's going to give me a list of all of the results that I have available. And we'll start off with displacement. So I'll click displacement. It's going to show me a displacement plot. I can animate this, so you're going to see it's diving down a lot there, but don't worry about that. We automatically scale up the deformation results, or not the results, but the animation. So all I have to do is come to here, change max deformation. Click that. I got a little slider here, so I can really exaggerate that. But what I'm going to do is I'm just going to click this the easiest way, and now this is showing the true deformation. You see, we still are getting some deformation in there, but now this is the true actual corresponding to these values up here, which usually is what we don't want for a linear static part. The deformations are relatively small, so I'm just going to bring this down just so we can see the behavior of it a little bit more than the true deformation, so we can see the behavior, but not have it be so ridiculous. And close that, and we'll take a look around. And you'll see that the results are animating as well, kind of going from 0 to nothing. And I can stop the animation. I can move that to wherever I want along the shape here. Show the deformed shape, which takes it all the way to the end. Or now I can come to here, and I'll take a look at von Mises stress. So we want to see the behavior of this, and we can see we've got some stress on there. I don't offhand know what the yield strength of ABS plastic is, but we definitely have some stress going on in there. And now I can, of course, animate that. We can see the stress there. But what I want to do in preparation for the next video, where we're going to talk about a few of the more advanced features, is I'm going to come over here and I'm going to click this snap bookmark. What that's going to do is it's going to take a snapshot of everything that I have set up here. So my orientation, and whatever I have animated. Let me come here and we'll come to displacement, and I'll take a snapshot of that as well. So I've got my displacement and I have my my stress. And that's going to make things substantially easier and quicker for us when we start taking a look at design modifications.